Hey folks, welcome back. Let's jump right into 4.5, which gets into mixed numbers and estimating. So when a proper fraction and a whole number are written together, the result is a mixed number. So we have 1 and 2/3, 2 and 5/6. So we'll be looking at those types of fractions. So the first thing we're going to want to do is be able to switch from one form to another. So we're going to go both directions eventually, but the first step is going to be writing an improper fraction as a mixed number. So it's a three-step process, which all revolves around division and subtraction. So first we want to divide the numerator by the denominator. So we want to see how many times the denominator goes in to the numerator. So we're going to see it in action though. The quotient is going to be the whole number part of the mixed number, and then the remainder will be the new numerator. And then of course the denominator will stay the same. So let's take a look and see what we got. So if we wanted to see what 13/7 would be as a mixed number, so we want to divide. So all of this is just going to be based off of long division. So if we said, okay, 7 goes in to 13, how many times? Well, 7 goes in once. So 1 times 7 is 7, and then we subtract to get 6. So now we have all the pieces we need for our mixed number. So again, the quotient, there's our quotient, and then there's our remainder. So this should equal 1 and 6/7. So again, the denominator doesn't change. That's it. So let's do it again. So we want to see how many times 5 goes into 32. So 5 doesn't go into 3, goes into 32 6 times. That's the most. So 6 times 5 is 30. Subtract till we get a 2. So again, there's the whole number part, and then there is the remainder. So this should be 6 and 2/5. All right, one more time. 7 goes into 79. 7 goes into 7 once with nothing left over. Bring down the 9. 7 goes into 9 once. And then there's 2 left. So this should be 11 and 2/7. All right, so pretty quick process. Eventually you're going to be able to do it in your head, but until you get the hang of it, just do a little scratch work on the side. Make sure you're doing it right. So if we want to switch it back now, we want to change a mixed number into an improper fraction. Now we're going to do the exact opposite. We're not going to divide and subtract. We're going to multiply and then add. So exactly the opposite. So multiply the whole number times the denominator. Add this product to the numerator. This sum is the new numerator of the improper fraction, and the denominator stays the same. So whole number times the denominator plus the numerator. And that is all going to replace your numerator. So basically you got 9 times 7 plus 3 all over 7. So 9 times 7 is 63, plus 3 is 66. So this should be 66 over 7. Same idea here. So we got 24 times the bottom plus the top. And that's all in the numerator. So 24 times 4 is 96. 96 plus 1 is 97. So 97 over 4. All right, let's keep going. What about this one? Can you do this one without showing any work? Yeah. 8 times 10 is 80 plus 9 is 89. So 89 over 10. And then we got this one here is going to be, whoa, the numbers are a little bigger, but that's okay. So 6 times 30 is 180. 180 plus 21 is 201 over 30. Now, what about lowest terms? Got a little bit of a bright spot, so I'm going to shade it a little bit. Can we divide out any common factors? It looks like I think 3 might go in, huh? So that looks like what? 67 over 10. 67 over 10. Now, could we have done this a little differently? We divided at the end after we changed it. Could we have divided out that 3 early on? And the answer is yeah. We could have divided the 3 out from the original mixed number. And if we'd done that, we would have got 6 and 7/10, and then we could have gotten to our 67 over 10 a little bit faster. So either way you slice it, you're going to get to the same result though. All right, so hopefully that makes a little bit more sense. Now let's see how we can use that to do some adding and subtracting. So adding and subtracting, we do have a couple of methods that we could choose from, but I'm going to push you towards one just because it helps fold into multiplying and dividing a little easier. So there's 2 methods. We can either change the mixed numbers to improper fractions and then combine them and then switch it back at the end. Or we can combine the whole numbers and the proper fractions separately. Now sometimes that is a faster way to do these problems, but we're going to see in some cases it's going to give you some icky answers, and you're going to have to do some adjustments to those answers if you want to get the correct answer in the end. So I'm going to show you both ways, but and eventually I want you to do it. I would prefer if you did it the improper fraction way, but it's not going to be up to you. As long as you're getting the right answers, I'm going to be happy. So let's take a look at this one. So 8 and 2/7 plus 3 and 1/7. So right off the bat, we have a common denominator, which is good. We like that when we're adding and subtracting. But if we use the improper fraction method, we'd say, okay, well, 8 times 7 is 56, 57, 58. So 58 over 7, and 3 times 7 is 21, plus 1 is 22 over 7. So now we can combine our tops, which gets you to 80 over 7. And then if we divide 7 into 80, that's going to go in once with 3 left over. It's going to go in 4 times. No, 11 times. Because I did a subtraction wrong. So that's going to leave you with 3 left over. So this should be 11 and 3/7. Now, compare this answer back to the original problem. If we had combined those numbers separately, the whole numbers and the fractions separately, look at what you get. 8 and 3 is 11. 2/7 and 1/7 is 3/7. So you're saying, well, why wouldn't we just do that in the first place, Lee? Come on. Well, like I said, some problems are going to be nice to do it this way, separately. Others not so much. So we'll just keep that in mind. What about this one? Let's do the improper fraction method. So we got 24 plus 1 is 25. 25 over 6. And this one, so we got 1 times 5 is 5, plus 1 is 6, so 6 over 5. All right, so far so good, but now we need our LCD because the denominators do not match. So what's the LCD between 6 and 5? So remember, if 5 doesn't go into 6 evenly, we got to take multiples of 6 until we get something that 5 works with. It turns out it's going to be 30. So 30 is going to be our LCD. So now we got to change our tops. So we had to multiply 6 times 5 to get to 30. So 25 times 5 is 125. And times that one by 6. So 6 times 6 is 36. So now we can add those. So it looks like 161 over 30. Well, 30 goes into 161 5 times with 11 left over. So we got 5 and 11/30ths. So now we can see if we had added the 1 and the 4 and the 1 together, we would have got the 5. But then the 1/6 and the 1/5, you would have had to change those and get in common denominators again, and then combine to get your 11/30ths. So you could have done it that way as well, keeping them separate. So there's nothing wrong. But like I said, some problems will give you a little bit yuckier answer. Let's do this one not using improper fractions. Let's do it the quote easier way. So let's see what we get. Well, right off the bat, we got to get a common denominator, so there's no way around that. So LCD would be what? Well, 6 doesn't go into 8. Next multiple would be 16. 6 doesn't go into 16. Next multiple would be 24. And 6 does go into 24. So 1 and 2 and... Okay, so we had to multiply by 4 to get to 24. So 5 times 4 is 20. All right, 8 times 3 is 24. So 3 times 3 is 9. Okay, so far so good, right? 1 plus 2 is 3. 20 plus 9 is 29 over 24. So there's where we can see a potential issue. So when these fractions are kind of big compared to 1, so 5/6 is pretty close to 1, 3/8 is, well, it's about a half. So you're going to get a fraction that's bigger than 1 when you combine those. So you can see here. So now we'd have to try to fix it, which is not hard because all you're really doing is fixing this improper fraction and then adding the 3 to the whole number that you get from that when you change it to a mixed number. Some people are good with that, some people aren't. But if you just do the improper fraction method, you avoid it altogether. So let's just do it the improper fraction way, and we'll see what the answer looks like that way. So we got 1 times 6 is 6, plus 5 is 11. We got 2 times 8 is 16, plus 3 is 19. We still got our LCD of 24, so we know we got to change those to 24s. And so then we want to multiply this one by 4, so that gives you to a 44. And multiply this one by 3, which gets you to a 57. And so now, if we add that up, we get 101 over 24. And 24 goes into 101 4 times with 5 left over. So 4 and 5 24s, we don't have to worry about messing with the answer. But it turns out that this would give you the same result. If you fix that 29 over 24, you'd get 1 and 5 24ths. So the 1 plus the 3 gives you the 4. So you will get there. It's really a preference, up to you which method you like better. Like I said, the improper fraction method, you don't have to worry about fixing your answer or anything like that. That's what's nice about it. So, all right, well, let's stop there, and then we'll pick up subtraction and multiplication division next video. All right, see you in a minute.